All right. Okay. Welcome back again. So let's see what we have next. We have run analysis and design, including load decomposition. So let's do this quickly. Okay. So go to analysis, building analysis.
Just before we go,
Why all the waste of time? What's going on? Okay, so don't forget to subscribe, don't forget to like, don't forget to share. And if you have designs, some complex designs you can bring. This is just for beginners, this is just for people who are just been introduced for the first time. So I don't want to do something complicated, I just decided to do something very simple. Okay. All right. So but if you have designs, you have bigger jobs you want to do, you can always contact me. Okay. Then if you also do not have our application, you can always get that. Check my previous videos. Also, go through my YouTube channels. You see how to get our app where you can have free access to all the tutorials. Okay. All right. So we are here again, and the next thing we're going to do is you go to loading combination. Okay. So load generator. Okay. So this is going to generate the load for you. Okay. The essence of the load generation generator is going to convert it to, we are doing limited design, and so the limited factor is going to be applied to, the service load, and it's going to convert it to ultimate limit state. Okay, ultimate limit state, with the factor 1.4 for dead load and 1.6 for imposed load. So that's what the load combination does. Okay, and okay, then we go to analysis, start. You don't need to activate anything here, just this is okay, then start. Give it a little time to run the analysis. Okay, that didn't take any much time. That only took 7 seconds, 19 milliseconds. Okay. Oh, this is beautiful. So let's go do load decomposition so we can come do the final analysis. Okay, so let's go to analysis, load decomposition. The essence of this is we want to decompose the load from the slab to the beams, from the walls to the beams. We want to now take care of the we want to take care of the gravitational load from up to bottom. That's what we're going to be doing now. Okay, so when you click on that, you come here. Okay, mesh uniformity factor 25. Just leave it at default. Shell element size, I can decide to take, let me use 700. The smaller the shell element, the more accurate the result. Okay, you can as well leave it at the default. Okay, but if you're doing a complex design, you have to always be careful with this, so you don't have your load comparison, your load this thing your load comparison. When you're checking your live load and your what do they call it again, I can't remember. When you're comparing your load, okay, at the end of the day you're going to see that you're having similar loads. I'm going to show you that. Let me just quickly do this. Just give it some time. Still loading. Comparison. Okay, still loading, just give it some time. Beam load have been calculated at all story. FE slab will be transferred to column directly when beams are not connected. In order to transfer FE decomposed load to beam, select all beams, blah blah blah. Okay, so that was cool. When you click cancel, it's going to ask you the last question. Now I want you to decompose all the loads to all for my entire model. Apply all to all beams in the model. Apply to all the beams in the model. Okay. And yes. So now we've successfully decomposed our loads. We go back to analysis, building analysis. Okay. Please quickly stop wasting time. Okay. So you come back to analysis, select your column, select your beam. You can reselect steel bars, okay? You can reselect steel bars if maybe the ones we selected you're not comfortable, but I'll leave it at this first, then start. Don't forget. Okay, so that took 20 seconds, 49 milliseconds, okay? That was very fast. So let's go to post analysis. Go to column. All our column pass, but you see this reinforcement is using white 13. This is not what I asked him to use. So we're going to work on that again. Let's check the beam first. The beam 2 pass. Let's check the reinforcement is using for our beam. 13, 13. I didn't ask you to do this, okay? Alright, so this is not a problem. This is not a problem at all. So what you can do is this. What we'll do is this, go back to analysis. Sorry, pre-analysis. Go back to edit materials. Let's see what happened. You see? A lot of things got selected when we didn't ask it. So just select Y12 and Y16 again. Okay, go to your beam. You see the same problem again? So I just need Y12 and Y16 only. Go to your slab, do the same thing, only Y12. Then your links, only Y8. Okay, I think this way. Let's check foundation. Rebar for foundation, everything scattered. I use Y12. Okay, and okay. So I haven't done that. We go back to analysis. We're gonna run analysis again. Start. Alright, so let's go again. Post analysis column. Still giving us that same problem. Okay, I know what we're gonna do now. So this is what we're gonna do. You come back again, select this, and you select this. Okay, let's check pre-analysis again. Everything is still selected. That's perfect. Everything here is good. Slab. Okay. Okay. So let's do it again. This time around, reselect steel bars. Okay. And start. Okay, post analysis column. Good. So we are good now. Y12 and Y16. Why are we having this here? What? Come on, this is unbelievable. Okay, so that's it about that. Then let's also check our beam reinforcement. Alright, so everything changed now. So what we selected, everything changed. So you can see them perfectly. You could see the spacing of the stirrup down here. You could check your deflection below. You can check the area of tear minimum for top, area of tear minimum for bottom. Okay, so you can see everything. Okay, so you can just be checking them one after the other. Okay, so I think our design passed. Okay, so most time people complain like what happened here. If you check, this is column 2C7. So we are going to find out this column. Most times you discover that your roof beam columns, the columns for your roof level. Most times you're having more reinforcement. Sometimes it's looking for a bigger section. The essence is simple. The reason is simple. Now, why is this simple? When you're designing columns, there are three things that comes into mind. Columns that are just axially loaded, there are no moments on those columns. Columns that are both axially loaded and subjected to bending in one direction, that is uniaxial bending. Then columns that are also subjected to axial load with bending on both directions, that's biaxial bending. So in a situation where you're designing the ground floor columns where there is axial load and there is moment, when you do column when you're working with the column interaction diagram, you see a lot of those things cancel out and you end up having minimum reinforcement. But when you come to your roof column, you end up having even more reinforcement for the same column that was even okay, and you'll be thinking, this is the same column that was carrying a smaller reinforcement with even more load. Why am I now having the same column on the roof load that is not even carrying much load having so much reinforcement? The reason is simple. When the column is subjected to more moments than axial forces, you're going to be having those problems, so because the column has to select reinforcement that will counter those moments. So we are going to quickly check this 2C7. We're going to check that let's go back and check it. Go to 2, then we are going to go to columns. Is 2C7. Let's look for it. 2C7. Okay. So if you look at this column is subjected to two major bending. There is bending in this direction. There is also bending in this direction because this bending here, there is more bending here. This cannot equate this bending, okay, because the beams are not the same length. So that is why you end up having issues like that. Okay, that's why you end up having issues like that. But what you can possibly do in most cases is, if you're having a wall load on this, definitely that wall is going to take some of the loads from the roof beam. Okay, so you don't necessarily have to reinforce it more. But in situations where you're constructing frame, you're constructing a frame building, it's important to put it into consideration, because when the moment is more than the axial force at this column, it's going to look for more reinforcement to counterbalance that moment. That's what happens here. Okay, so we've been able to do that. So let's see how we can generate our reports, our design reports. Okay, we are not done. We need to design the slab. So we're going to quickly design the slab. So you go to analysis, go to okay, go to concrete design, go to slab analysis and design. Okay, now check. Okay, we need to do something first. I've not actually done my strip. I need to put strip before I do this. Okay, so let's put our reinforcement before we go there. So for you to put your slab strip, for Protastructure it is called slab strip. Okay, so you come here, you click on slab strip. Now you have to set the end condition. This one means at the end is closed, at the other end is closed. At the starting end is closed, at the ending it's closed. Okay, so and I'm going to be running the x-axis strip first before I now go to the y. Leave it at an analytical strip, leave it there. So you click here, hold down your control key so you can have a straight line. Okay, you can see your reinforcement has been established. You do the same thing for this side. Okay, do the same thing here, and you finally do the same thing here. So when you're done, you go to the y, do the same thing for y, do the same thing here, and do the same thing here. Alright, so after this we can now run our analysis. Okay, so you go to concrete design, slab analysis and design. Okay, check design, only reselect insufficient steel. Okay, reselect insufficient steel, or let me say, yeah, delete and reselect all steel bars. So you can choose any of these two. Okay, so let's design and see. Just give it a little time. The design is ongoing. Okay, so our design has been completed. Okay, and you can see the reinforcement at the right side. You can see the area of steel provided, and you could see the reinforcement and the spacing for each of them. Okay, you can see them. Okay, deflection check sufficient, so you also have to check the deflection if deflection is good. So we are going to check that very slab that has been a major concern to us. We're going to check it. Okay, so this is it. You can save this as a PDF. You can save this as PDF, or you can send it to Word. Alright, so I want to quickly check this guy. I think this guy is good. If not, we will be having issues, but I think the guy is good. Okay, this is 1S8, so we're going to check again in the 1S8. Let's check. We need to go back here. Okay, let's check this. Let's do this slab deflection check. So let's do this first. Okay, so 5 years or more, so that's my limit. Detect automatically, allow the software to detect automatically. Check deflection. Apply to selected members, no. Apply to all members in the current story. Okay, so let's check deflection for this. Don't forget, this is 1AS8, 1AS8, this very one. So let's check deflection, especially for this. Just give it a little time, it's still leveling. Good, deflection check. Alright, I am looking for, this is 1S1, so let's go to 1S8. Let's check if it passed deflection. If it passed, we're good. Good, this is the guy. Deflection is adequate. Beautiful. Deflection is adequate, so there's no point being scared. 1S8 is adequate. So you can see deflection is good. Crack width is okay, is within limits. So you don't have to bother yourself more about anything. So you can also do generate your reports here. Okay, you can click here to generate reports. Okay, so for the column and beam reports, let's go back here. Building analysis. Oh, this is gonna take another time. Oh shit, I should have done this before now. My system is kind of slow. Oh shit, what's going on? Okay, post analysis, column and wall design. So here you can generate your report here. It's very simple. You just come to design report. Okay, just click on that. It's going to generate the design report for you. Include all load combination, include interactive diagram. I need it. Include columns, row, section in the report. I don't need that. Okay, so it's going to generate the report for you. It's currently generating the report, so you just have to be a little patient. Okay, so this is it. This is the column interaction diagram. So for that column 2C7, you can check it out so you see the level of moment on that column. 2C7, okay? So you see that. You see that, okay? This is 2C7. Then, okay, so this is design moments. This is design. This is the axial force on that, very small force. And you're having M22 30.9. Okay, so then you check this 0.029. Okay, so by the time you take this with your d all over h to check the area of steel to check the steel percentage, you end up having 8y16. Okay, that's what definitely you're gonna have. That's what you're gonna have, because it's as a result of the excess moments on that column with very less axial force. Okay, all right, so you can also save this as PDF. Simple. You can do the same thing for your beam. You go to beam, then you also design report. Okay, I don't want it to waste time, so you can do this on your own. All right, so that is that for that. In our next class, we're going to be looking at okay, we've done generating report. That's supposed to be in the next class. We've done that already. So we're going to be looking at detailing with product details. That's going to be the next thing.